Okay, so the next step is to understand the Java implementation of our microservice. The responsibility of our microservice authors is only to provide data over a REST API related to authors. We can request a specific author and the data of them provided in a JSON format. In this lab, we have the focus of understanding the source code and the implementation and configuration. Let's take a short look. So we have defined a POM file, we also define a server file, and we have 4 different classes, authors and other classes. And we will take a look to understand how we do the implementation with MicroProfile. Let us start with the POM file configuration for our project. POM means Project Object Model. This file contains all we need to build our project dependency, build, and other properties. For example, here is the MicroProfile dependency. Let us move on to the configuration of the OpenLiberty server. In the server XML, we enable the web profile for Java Enterprise applications, MicroProfile. We define our HTTP endpoint and the ports. We should keep in mind that the port 3000 will later on exposed inside our Docker file. Then we configure the web application WAR file name and the context root we use later. After we have finished the specification of our project with the POM file and the server configuration, we move on with the implementation of the Java classes using MicroProfile. Here are some basics about the MicroProfile you maybe remember. MicroProfile has 3 major layers. The bottom layer is the RESTful implementation help for the developer. The middle layer is to help writing microservice to operate them and manage at scale. And the top layer helps to write observable microservice to detect or diagnose issues. Let's take a closer look to the classes we need to expose our author service. We have 3 major classes here. The authors application class represents our web application which runs on the OpenLiberty server. The author class represents the data structure we can use inside our microservice. And the getAuthor class represents the REST API. And as you can see in the class diagram, we use the author class inside our getAuthor class. We will take a look later in the implementation for that. As you can see inside the authors application class, we do not implement any additional logic. We only provide the version name of the application so that we later have the version path for our REST API, and that's all. Now we take a look at the class author. This class contains the data structure we use inside Java applications. When we got the JSON information over the REST API, we extract the information and put it to that class so that it can be used inside the Java application itself. And that's all. Inside the class getAuthors, we use from MicroProfile, JAX-RS, and OpenAPI, so the bottom layer and the middle layer. So now we take a closer look to the implementation of our getAuthors class. And as you can see, we use a lot of annotations. The annotation, for example, from the JAX-RS is the path. We get the author, and remember the combination we must use later, that was the version path of the application itself, version 1, and then these getAuthor, so that's our REST endpoint at least. So then we specify the command with the annotation, and we use from the OpenAPI, we use the annotation API response for the documentation of our REST implementation. With this information, MicroProfile will build a Swagger Explorer directly running on the OpenLiberty server, so we do not have to do additional implementation, having a full documentation and a testable documentation of our REST API. Inside our implementation of the response for the getAuthors, we can see we use the authors class, as I said. The authors class is the data exchange class for us here in our microservice. If we maybe get data from other database and we provide it from here, we would fill this class with the data. And for the response itself, you create a JSON format to send it. Later you can change the values inside this class to reflect that you can change the source, and we really build the new microservice based on the given source code. Let's move on to health check, supporting live and readiness probes in Kubernetes. Kubernetes provides liveness and readiness probes to check the health of our container with our microservice. With MicroProfile Health, we can expose readiness and liveness endpoints for our microservice so that Kubernetes can pull these endpoints as specific probes to react appropriate to any information and change maybe of the microservice status, so that we have meaningful information in our log. This is given out of the box with MicroProfile Health Check. We do these with the implementation of the health check, and as you can see in the health check endpoint class, we directly define what we give as a return, which data. For example, here we will provide the information when we check the health with authors, that authors is okay. So that's what we also define in the deployment YAML, as you can see here. And you see the curl command on the local container. These commands will be executed locally on the container inside Kubernetes pod from Kubernetes itself, or if you call the health check by yourself externally. After all this understanding, move on to the hands-on task. We will now change the implementation of the microservice itself, the return values, and then we will execute the microservice locally on the Docker container. First, we ensure that we have opened up the local terminal and not the terminal with the running Docker image with the pre-installed tools. And we verify that we are in the right workshop directory. That's okay, so we can move on. Now let us change the source code of the microservice with values we want to provide. I change it to my Twitter account, my name, my information. You can do it for yours. Just watch. After this, we build our Docker container locally. Remember the multi-stage build. And then we can execute the local Docker container. We can copy and paste the command and execute it. Let us open up the OpenAPI Explorer of our microservice, which runs in a container on our local machine, and verify the REST calls. Now we try out getting the author information we inserted just by try out. Insert the value we search for and watch the response. It works. You remember I added my name and my information, and in the path you can see the context route we defined in the server XML and the version in the application and the REST call path. Now it's time to move on to the next step. Bye.